Okay, everybody, we're gonna get this started then and kick this off. It's prime vacation time. So I think a lot of people are out on vacation. So today we're going to talk about Armis. So myself and my colleagues are from Armis Federal, and we're going to talk about unified asset visibility and security. So I'm Joe Hamblin, our public sector CTO. On the phone with me, I have Martinez. He's one of our lead solution engineers, and we have Bryan, Inman, another one of our solution engineers. And with that, we'll get right into it. So we're talking about the unprecedented growth in assets. So as time goes on, you see this march over time. There's the number of IT devices stays like work laptops and workstation, for example, stays relatively slow growth, but the explosion in unmanaged devices is going crazy. You see, and what's driving this is all your IoT devices, those devices, 90% of assets in any given enterprise are unmanaged. They're not identified as what they are. So we're calling this the visibility gap, and we're going to go into and explore that in detail here today. And we expect that trend to even get further as time goes on. There'll be more and more unmanaged devices out there. So the visibility, 90% of IT professionals have, things are dynamic. The industry we are, the old days of castle mode are unfortunately long gone, and now your perimeter is sort of no more. It's everywhere. So it's very critical now. It's important to know what these devices are and to know what your potential vulnerabilities may be regarding those devices. So zero trust, we all know, never trust, always verify, and the visibility. Do you know everything on your network? I've gone through several FISMA, high recertifications and so forth. And one of the biggest challenges that when you go through that kind of process is you have to identify everything on your network. It sounds sort of straightforward when you're talking about an on-prem kind of environment. However, it can be quite difficult. Generally, you're trying to track down some IP address, where is the device? Oftentimes ends up being an IP camera, smart TV, or something like that has to be, you're not able to complete your certification until you can identify everything that's in that FISMA environment. And then the next thing is, do you know the vulnerabilities that these devices on your network may or may not have? So that's the criticalness of the visibility gap, and we'll explore that as we go forward here. So I'm going to jump right to the zero trust matrix. A lot of us, that are dealing with zero trust, this is what people want to see. You see the pillars across the top, and then the different sort of functional areas down there. And what I'm showing with the green, these are areas that Armis does 100%. We provide solutions for that. So you see in the device endpoint, we pretty much own that space. We do everything in that space, and then we work in other areas as well. The visibility analytics, the network environment, and then you see the ones that are in like a purple or a magenta. Those areas that we operate in, but we don't meet all the requirements of that area, but we meet like half or more of those requirements. Anyway, well, a note here I'll make is that it's interesting that on the GSA civilian side of the government, they have the matrix you're looking at. On the DoD side, they have a slightly different skew or vision of this. So there's sort of two sort of schools of thought on zero trust. They're similar but different. And then I want to explore what an IoT device is. It sounds like maybe everyone should know this, but I find more and more when I'm talking to customers that that's not the case. Everyone, IoT devices are thought to be like a dumb device. You plug it in, it just works. However, it's important to realize and not forget that IoT device, that IP camera, smart TV, whatever it is running an operating system. It's running in Windows or Linux, pretty much like 50-50 split between those. And the way you manage those devices is also different. Instead of doing a patch, you do a firmware upgrade. And that makes it difficult, because you usually have to visit a device. Also, when the device rolls out of the factory, so if you're talking like an IP camera, that IP camera rolled out of the factory at like 2018. That's when that operating system is from. It's from 2018, possibly even 2017, and it's frozen in time. So whatever vulnerabilities have happened to the operating system from that point in time, that device has those vulnerabilities. So again, so it's not a dumb device, and it has vulnerabilities just like an operating system. And so I think oftentimes they're not appreciated, the potential attack vector that IoT devices offer. So again, we'll talk about the visibility, and this is just sort of showing the different sort of where these different like IT devices, network, mobile devices, sort of where they are from an on-prem and different stuff. So you see IT, network, and then as you start moving up mobile devices, you have your so they sort of cross the line. Sometimes they're inside the premises, and other times they can be outside the perimeter. And then you see cloud environments, work from home, edge devices. So you have devices that interact with a given agency, and these devices could be in multiple different locations. And like in the case of a laptop, it could be at home, it could be in the office, and that actually presents challenges oftentimes from an IP address or deduping, where one of the common problems with a lot of these environments is these devices can move around, and you want to report one device. You don't want to report multiple devices when it's really the same device. So at Armis, we're able to see through that and know that this device was the same device that was seen on this other network yesterday or earlier today. Is instead of being reporting as multiple devices, we'll actually report it as the same one device. And I think probably the question that everyone is asking out there is from a Fedramp perspective. Armis, we are a SaaS offering. So where our Fedramp status today is that we are in process for moderate. We expect to get authorized. We're just final days. We're thinking like a week or two weeks. We'll have our authorized for moderate. We also are in process for IL4, pretty far down that road. And we expect, in fact, we expect our sponsor to do their ATOC, which means they can start using our solution probably in early September. So we're pretty far down that path as well. All right, moving on here. So we'll sort of explore this live map of your access, sort of like this here, so you sort of see it. So the first thing, we're going to discover assets, and we'll get into how we discover assets here and a little bit further. And we're discovering. I think I'll save that for later. I'm like, so, and then once we discover devices, we want to enrich them. So now we're going to say, so we discover a device. Let's say it's an IoT or an OT device. The question is, what is it? What operating system is it? What manufacturer is it? So this is where we use our asset intelligence, and we say, okay, this is a smart TV. It's running this operating system, this version, and we'll save here, and then now we're going to map the contextual relationships between the devices, how things communicate. Are they communicating outside of that environment somewhere, maybe some out nation state that they shouldn't be talking to. So all these details are all mapped at that step. And now we're going to detect the vulnerability. So once we've characterized it, enriched it, now we know that, this smart TV, this HVAC system, it has, this vulnerability, and then or threat, and then we'll rate them or prioritize them, and customers can modify them. But out of the box, we do it. Customers can change that behavior depending on what they want to do. And now we take automation. This is where we see something, we can tell the device to move this device off the network, or take action, alert on it, however you want to do it. And so when we say unified asset management, we're talking about again, OT devices, IT devices, IoT devices, as well as medical devices. So we span the entire gamut of all these different environments. And then a core thing is we're a SaaS offering, and we have no agent, so we can get up and running very, very quickly. We're talking hours, and you can start getting value out of it. So we have a lot of success that a lot of customers in the past. Some of you may have dealt with some of the programs like CDM, continuous diagnosis and monitoring, and one of the challenges with that was the expense and the time it took to get a lot of those solutions up and running, start getting value from it. So with Armis, again, with leveraging our Fedramp, environment and the fact we have no agents, we're able to get value, day one. And so also we have a rich API that you can integrate with if you want to or need to. We have, and we're going to explore this here in a moment. We have a very rich set of adapters for different, like ServiceNow, for example, or your EDR solutions. We have pre-built integration with those out of the box, and zero impact on the network and devices. So we'll get into our knowledge base. So this is our AI engine, runs up in our cloud environment, and you'll see, and this is where we'll categorize. So we see generally the problem is that when people look at what's on a network, 70% of devices or 65%, they'll say, oh, this is a laptop or server, and they'll put that in their CMDB, be it ServiceNow or whatever they're using for their CMDB. Now for the unmanaged devices, all they generally capture is an IP address. So they'll have, and once in a rare while, they'll capture a MAC address. And that's so the CMDB all is going to have for this all for the device is an IP address. We will see that IP address and we'll say, oh, this is again a smart TV, it's an IP camera manufacturer. So we're gonna categorize all this and then update the CMDB with what version operating system, what manufacturer. Also, you get into your FAR 889, meaning you're unauthorized, you're not allowed to say use a Huawei device and other devices. We also will capture that. One of the situations one of our customers ran into was they bought a IP camera from HP, and unbeknownst to them, it had a Huawei chipset in it, and we picked that, detected that, and alerted on that. So that's all happening in the cloud here. In our Fedramp cloud environment. We also have over 2 billion assets that are currently being tracked and monitored across our environment. So quite a large, and we have about 16 million profiles. Profiles are how we categorize a device. So is it an IP camera? Is it a infusion pump? Whatever it may be, that's where those profiles come into play. And if we see a new device, then we'll categorize that. And that turnaround for that is hours. Also, we know how a device behaves. So like think of like an IP camera, IP camera or a smart TV. There are certain characteristics of behavior of that device. So if we see we call it like known good. So if we see a device, an HVAC system or something, and it's outside of its pattern for behavior, we'll flag that as well. Generally, that means like a botnet or something like that. Something has happened to that device, so we'll report on that and detect that as well. So this is I talked about earlier, the collector. So Armis, we collect data in two ways. So we collect data. Number one, we collect it from the network. So we're providing data and value that the customer doesn't have today. All their systems, their EDR systems, their NAC systems, what have you. We also getting this from a standard tap port. So as soon as something hits the network, we'll see it, and then we'll feed it into our threat engine as well as our knowledge base, and we'll categorize it, and so forth. So that's how we're able to see in real time, what's happening on the network, and able to provide intelligence on what we see on the network. And then we collect another way is we get it through our integrations with other systems like EDR systems and your Taniums, your vulnerability systems. We have out of box. We have things that we have a couple hundred of these integrations, Gigamon, all these Rapid7, Tenable, Tanium, all those kind of things. So we have it's out of the box. Boom, you integrate. You connect it and it's done. You don't have to write any code. It's just there's a wizard that walks you through it. So we with that insight, you'll see when our engineers do the demo, you'll see we actually will categorize where we get the data from. We got this data from Armis directly. We mean our network collector, or if we got it from the EDR system or ServiceNow, Tanium. We define the sources of that information. And then I wanted to talk to some of the protocols. We support, there's actually probably more here that we have. This especially comes important when you're dealing with the OT environment. OT environment in particular have lots of different proprietary, if you will, protocols. So we support all of them. And even on the medical side, there's some protocols over there that are unique. So this allows us to have full coverage of your OT environment as medical as well as your IT environment. And with that, I'm going to hand the ball over to Bryan. You can grab the screen for me, Bryan, or I'll stop sharing.
Yeah, that'd be great. And I will pick it up. So it looks like we have a relatively small forum. So I think it's appropriate to sort of pause. I want to keep this interactive. If there's any questions, please feel free to drop them in the chat. That might help me steer some of what the content that we have. There's a lot of great things to show within the demo environment, but please feel free to drop any questions in chat. Myself or Eden or Joe could grab them, or just jump on if you want and let me know if there's a certain question you might have or a direction that I could steer this. But at face value, what we're looking at is your traditional Armis tenant. And in essence, we're looking at the bucketized view of what Armis has discovered, right? So as Joe pointed out with all those slides, kind of sort of, the wizard behind the curtain type of thing, how do we do what we do? But this is the results that we're going to look at today, which is, in essence, as we discover these devices real time, be it through traffic inspection, as these devices communicate north, south, east, and west, we passively monitor that network traffic, and we glean a lot of the metadata off of the packets that we glean, right? So nothing sensitive of the payload is sent up, just for clarity, but we do glean, some key information, source and destination IP, MAC address, etc. Some of the metadata, ports and protocols, and we'll get into that a little bit more, but essentially, we're able to glean a lot of information off of what we get from that passive inspection. We identify what the device is, and we categorize them into these buckets that you see here, right? So everything that's communicating on your network, again, north, south, east, west, a lot of the devices you'll see here that sort of call out are some of those ones that are unmanaged, unmanageable, right? You can't necessarily scan them because they're sensitive, or you may not be scanning them because simply you didn't know about them from an IoT perspective, or they're sensitive from an OT, right? Certain PLCs and really critical devices that you're unable to scan or to put an agent on to call back, right? So how do we detect those? How do we figure out what those are? How do we figure out with a little bit more depth to that too, not just what the device is from a hardware perspective, but what lives on that device as well? Does it have a certain operating system running on it? Does it have a certain set of applications that are running on that? And if so, what are the versions of those? And then even further, that's when we start to apply that knowledge-based and threat detection engine to say, okay, I know about those, and I'm chock full of risks associated with those known bad indicators of compromise, right? Through network traffic, I can see what that device is trying to call out to or is actively connecting to. And that's a malicious website, for example, or it's using a very highly compromisable version of a web browser, for example. A lot of CVEs associated with that patch version of that operating system, right? So we'll get into a lot of those, but at face value, a lot of folks really love the simplicity of just what is on my network? How can I dig into some of these tools? And then, of course, where are they on my network? So on the top right, that's where we start to break down from our boundaries and our sites, right? So sites is a physical representation of the data, right? So we do that through subnets and access switches that we detect and all those good things. We're able to say, okay, I know where these switches are. I know it's talking to these switches. I know what these wireless link controllers and access points are and where they are. And we start to divvy that out to give you that physical representation of where the data is, but also a logical breakdown of that too. And this can be anything unto your heart's content, right? Of logical representation from this is my guest network, this is my OT network, this is my employee Wi-Fi network, right? Sort of however you communicate about your network today is how we organize so that you have a very simplistic view and are able to dig into the areas that you care about for whatever reason at that particular point in time, right? So I'm looking at this view, and all the views we look at when we pivot to dashboards, et cetera, can be organized by this and isolated by that to show you the data that you care about at that moment, right? So, and of course, time frame too. So let's dig into a little bit more detail on an IT, something simple, right? So something a lot of things folks know about, right? Let's pivot to our table view here. Oops, I added a portion of the query. Let's pivot to the table view, and we'll take a look at something, a little more common, right, to start with. But the idea behind that, and even at face value now, we can start to see how we're providing that single source of truth by not just the traffic inspection, but also integrating with the tools that you have in place currently, right? So we'll integrate with those for a couple of reasons: to gain better understanding of what the device is, and in terms of identifying risks and identifying what the device is, but also to give you that cross-pollination of, that single source of truth of what's on my network and what's on those devices. So from this particular instance, we see, at the top right, it's broken down by the device categories, and we can look at types and organize this graph, however we want to, really. But towards here, we can see the data sources, right? We see a laptop computer, it's a ThinkPad Lenovo, but here's all the data sources that's associated with it. It is an Active Directory. It does have a CrowdStrike agent, right? It's got a person with Palo Alto networks. It lives in SCCM. It is in my service now, right? So you can see these. And then, of course, too, I'm actively seeing it communicate on the network, right? As recently as August 13th, this thing was communicating. It's a demo environment, but it would obviously keep up with that in real time. So let's open up and dig a little deeper into this and see some of the enrichment that we get behind these types of devices. So again, we know that it's a Lenovo ThinkPad. We know that it's running Windows 10. We've just talked about the data sources and the cross-pollination of that. We see it's got an IP address. We see it's got an IPv6 address, which that's becoming a lot more prevalent these days as we shift closer to the IPv6 inevitability. But we see the MAC address. Towards the bottom, we see custom tagging, right? So we can tag these to your heart's content again, right? Anything you want. Corporate, you could tag this, hey, critical asset, or you can tag whatever the use case may be. You have a very customizable tagging feature. We can set policy to say, hey, for example, any device coming in from this subnet, I'd like to tag it as such, right? As belongs to this owner or something to that effect. But you can tag a very customizable tagging feature. To the bottom, we can see where it's where it's located physically. We can see down, how it's getting onto the network as well, to which switch and gig port that we're looking through here. And then, of course, first and last time seen. To the right, we can see all of that cross-pollinated information, right? Not just what's on it, but we glean information. We're very specific in our APIs and what we're reaching out and pulling back in, right? Tanium agents, we pull a lot of great information in from them. Your antivirus or endpoint detection, types of integrations that we have, we're able to give you that sort of what's the health of this device as well. What users are associated with this device? That's a really powerful portion from maybe an insider threat capability. What are some users associated with multiple high-risk devices in our network? Is there a commonality behind the user with it? We can see, again, as we scroll down, the firmware, the operating system, versions of it, its status within SCCM, is it getting the most recent patch updates? All kinds of great information that you can glean from this single source of truth. Again, I'll say it again and probably more times, of what's on my network and what's on those devices. Looking at the network stats, right? Again, monitoring the network traffic, we're able to glean, how's this device communicating internally and externally as well? What ports and protocols is it using, and probably more importantly, what is it communicating to, right? Some malicious domains. We leverage, for example, VirusTotal to help solve some of these equations as well, but all kinds of third-party threat detection engines for indicators of compromise to help us figure out not only, is it talking to something bad, but also, is it supposed to be talking on that port and protocol, right? And we'll talk about an IP camera in a moment, but for example, we know what thousands of other, Lenovo's or thousands of other IP cameras of the like are looking like when in terms of a network behavior. So we can instantaneously baseline and alert when something happens outside of that, right? Like as soon as we plug this thing in and we see that through network traffic, this IP camera, for example, is talking somewhere it's not supposed to be, instantaneously raise the risk score of that. And we'll talk about that here momentarily. But again, more than just showing you a summation of other integrations that you have, other tools you have in play, we're getting that live traffic inspection and figuring out what's communicating on my network in real time. So as we pivot down again, ports and protocols used, we apply security matrix to this as well. So things like, hey, do we see, FTP spiking, right? File transfer protocol. We see this thing talking outbound via FTP. It's dumping a lot of traffic off. We're gonna alert on that, right? We're gonna raise the risk score of this device, and we're also gonna alert, as we can see here with alerts momentarily. Services being ran. We can see a lot of things. Our service usage, we'll talk more about with applications in a moment. But again, things like Tor browsers, are we seeing something malicious like a Tor browser? Maybe not malicious, but usually not used for good with Tor browsers. Are those downloaded and being actively used on my network? Again, applying that underpinning of security that encompasses the entirety of Armis. The activity logs. So this is sort of that lowest unit of measurement, right? And this is where we apply a lot of great things like the MITRE ATT&CK framework, for example. This is sort of everything that this device is doing broken down to what we call activities, right? And we can search for all kinds of different ones. Again, we talked about the instantaneous baselining, if you will, with abnormal behavior. Is it exhibiting abnormal behavior based on thousands of other devices that we are monitoring and know what known good looks like, and instantaneously apply abnormal behavior or anomalies detected, right? We can see things like brute force attempts. Is this thing consistently trying to knock on someone's door and bring up the credentials password, etc. Credentials expiring soon, credentials that are invalid that are in use at the moment. All kinds of PCI things, default passwords that are being used, right? The list goes on and on. A ton of different activities that we are paying attention to and alerting on through, again, leveraging things with like the MITRE ATT&CK framework, recon type of activities, etc. So those are underpinned, and then of course are able to alert on those as well. We'll talk about vulnerabilities a little bit later, so I'll save that. But applications, again, what's on this device? What are the versions associated with that device? So twofold here from a security and from a licensing perspective. If you could tell, in real time, how, let's just say in the last 30 days, how many devices on my network are actually using whatever, Microsoft Office, for example, or some version of Adobe. Well, I'm paying for an enterprise license for it over here, or maybe I'm paying for 1,000 licenses, whatever it may be. I'm actually only seeing maybe 300 to 400 devices on my network actually utilizing that. So we can instantly cause that, that cost savings by real-time data of what's being used. But then also again, I don't want to steal the thunder from vulnerabilities, but what vulnerabilities are associated with those versions of not just the operating systems or the hardware themselves, but also the applications running and the versions in there. Something as simple as a web browser, right? Knowing what version of Google Chrome's being used out in your environment is critical nowadays with all the 0 days that we have exhibited as of late. So then too, even at face value, as we pivot over, I wanted to show off a little bit of the query language. And what I'm going to do is basically just run and start to look at, again, the simplicity of the dropdowns, right? It's like, syntax, but with dropdowns. So it's made a lot easier. If I want to search by devices, applications, certain types of alerts, all the activity types that we're seeing. Activity is a great place. So that screen we had just shown, sort of a threat hunter's dream, right? When you can have the ability to look at the specific device, know pretty much everything you need to know about that device, but then how's it behaving and be able to hunt down those types of bad malicious behaviors, or to search through those activity types and IP, connection types to say, hey, is this, a new FBI ICS list just dropped down, and I need to look to see if these, if any of my devices are trying to communicate to these 30 now known really bad IP addresses. We could do that within, copy and paste it into this query and take a look from a threat hunting perspective. But what I want to do is talk about the risk factors for just a second. So again, showing you not just everything about the devices on the network, but applying, some really commonplace practices by leveraging the research done by the Armis team and providing that through the knowledge base, right? So if we just look at all risk factors, we call them, and we'll look at the high ones. Right off the bat, we're seeing things that I get a lot of great feedback on this one, which is, I need to find all of my operating systems, all of the firmware versions, and all of the software versions that are no longer supported by the vendor. That's something we're looking for consistently, right? So you can look through in the past, again, all time, how much of that is running on my network, be able to instantly apply that very easily. SMBv1 usage, right? We can detect on that. Obviously, very vulnerable way of talking with internally to the network. So, and it's very susceptible to ransomware. You can kind of hop on one and ride that to the other devices in the network. So how many devices are actually using this extremely vulnerable version of SMB? And so on down the list, right? Looking for all types of risk factors loaded in there. So I'm going to pause. I don't see any questions in chat. Please feel free to jump in. If you have any, I'll drive very quickly over to back to the inventory page. I want to show something like an IP camera, just because it does a couple of things for us. So we take a look here. So again, if you notice the difference on this page from the previous page of the Lenovo, we're looking at just a data source of traffic inspection. And that's important because to me, that really illustrates the ability to say, okay, I know that I knew about that Lenovo, obviously. It lives in so many other tools and great. But imagine now applying that to whittle that data source list down of, okay, I have this ThinkPad over here that has everything, it's good to go, it's the perfect device, great. But what about this Lenovo over here that's, you know, I've only seen it communicating via traffic inspection. It doesn't have an endpoint agent on it. It doesn't live in SCCM, right? So now I can start to apply that logic to really repair some of those gaps that we see, but all the way down to just traffic inspection, right? We're not going to be able to put agents on an IP camera or scan that with a vulnerability scanner. So Armis is, you know, one of the big differentiators with the knowledge base is this ability to say, I see this thing communicating on the network. That's all I have to go off of. But from that metadata, I'm able to glean the IP address, the MAC address, right? I broke that down into a boundary and a physical site. I know the make and model of that. I can see through, again, just traffic inspection. I see it communicating with these types of applications running on those, OpenSSL, Apache, the versions, etc. Same logic applies to those. But now let's talk about the alerting features, right? So we see network traffic from this guy, obviously. So here's how it's communicating and what it's communicating to. And this is that logic applied that we just talked about a moment ago, which was we know what all these types of access communication cameras are supposed to be doing. And we see this guy instantly behaving outside of that. If we open up, we've got a critical alert associated with this. And here's why. We see it communicating over port 80, something not common at all from these, out to, you know, out external IP addresses, etc. Whatever the case may be on this one, we know instantly that this is indicative of a botnet infection, and it's something that we need to take a look at instantly, right? The risk factors that we were looking at too. We see the threat detected that we just talked about. There's some vulnerabilities associated with these applications. And then of course, you know, hey, this manufacturer, we usually kind of block these ones out, but the point is we leverage that knowledge base to apply that to what the devices are, what they're running, and then how they're behaving on the network to really give you what's on your network, and then enrich that with security through risk factors and vulnerabilities. And from there, I will pause and kick it back to Joe for some more content, and then over to Eden for some additional details. And hopefully I'll sum up with our vulnerability management that was newly released. So Joe.
Thank you. Let me share again. Wait for that to go. Okay, great. Thanks, Bryan. Okay, we will go to the next slide here. So some of the critical questions that Armis addresses. We talked a little bit about this. The CMDB. Is your CMDB clean? Is it accurate? Like we just, and Bryan showed you, and we talked about earlier, oftentimes or almost always for your IoT, OT, and so forth is not. So we can enrich that, you know, and you know, give you, instead of just having an IP address, you know, we can complete that so that, you know, your CMDB will be accurate. How many laptops? This is a comment. How many laptops do you have? This is sound like a simple thing to do, but it's very hard to do. So we'll go into customers that'll have like, you know, big environments, like 50,000. One of our DIB, defense energy-based customers, had 50-some thousand laptops, and that's what they were seeing in the EDR system and their vulnerability management. They had two different numbers. The EDR system was reporting one number, the vulnerability system was reporting another number. So we can actually, you know, look on the network and figure out exactly how many devices are. And then it's quite common to find that, let's say they make a nice round number, say 20,000, and actually they have, for whatever reason, maybe like, you know, 300, 400 machines are not being managed, are not under management by the EDR system. So we can detect that and report on that as well. and as Bryan showed you, what application, what version. And again, on the IoT devices, it's not a dumb device. It was, as Bryan showed, it was running a certain version of Apache and some other technology. So vulnerabilities could be present in the versions of the running of those applications on that device. And then the device and IP, we talked about this before, we're able to dedupe that. It's a big problem that most agencies are struggling with is cleaning of their data. So they're deduping the IP addresses because, again, laptops move around. It'll be common is that the existing systems will report that as multiple devices because the IP is addressed. They're not able to say this IP was a laptop that was seen over there, a week ago. So we're able to see through that and clean that data up. And then, obviously the 0-day, security advisories. In fact, Armis, we were contributing on the OT environment, always looking for vulnerabilities, and we reported some 3 vulnerabilities that existed for UPS systems. Everything is being IP enabled now, so UPS system now talk to the cloud as well. So we reported some 0-day attacks that existed for those devices, and then we came up with a way to detect that and mitigate that. And then we work in the cloud environment as well. So how many virtual cloud assets do you have? That also applies to your VMware virtual environments as well, because you could have a rogue image that pops up. So we'll see that and make the environment aware of it. And then, are you compliant with your CIS controls? And then lastly, your 853 controls, which ties into your FISMA as well. FISMA tends to be a more static approach. There's a version update to that Rev 5 that's out right now where they're trying to make that more of a dynamic environment. But if you had your FISMA audit, if you got your FISMA certification in like 2018, generally they're good for like 3 to 5 years. The system may have drifted from the original certification, so we're able to detect if you're, and we do that in a couple of different ways. We'll do that with data that we collect. We'll do that data we consume from your other systems in your environment, report on that. Okay, and then so multidimensional asset views, and Bryan did a good job of walking you through all that. I'm not going to belabor that because Bryan already showed that to you. Identifying risks and asset threat detection, and Bryan's going to touch on that here later. We have a rich solution around that where we're able to prioritize that. Again, like I said, we have some customers who want to provide their own intelligence as far as how they prioritize the threats. So that's also an option that we support. And enforcement. So enforcement is, so now we detect all this, we know that this is vulnerable and so forth. This is where you take the action side of it. So now it's vulnerable. What are you going to do about it? So here you can take several actions. You can kick it off the network. Tell the switch to kick it off the network. Put it on a remediation network. Tell the patch managers to patch it. Report on it. Send it to your SIM solution and all different. You can how whatever type of action you want to take. We can. Armis has that ability to take that kind of action. And then this is just showing some of our large, I won't go into the federal customers here, but with some of the breadth of customers we have. And like I said, we're on the DoD side. We're working with we have civilian customers, civilian government customers as well. And with that, I'm going to pass the ball over to Eden, and Eden's going to show you other aspects of Armis. I'll stop sharing.
Sure. Thanks, Joe.
Yeah.
All right, share screen. So one of the great things about Armis is we are very much a platform play, right? An enterprise. How do we help with not just your traditional IT, but also your IoTs? You saw a few examples there with Bryan, and your OT, your MOT, medical devices, right? So to touch a little bit on those other areas, OT and medical, I think we do a great job of not just being, again, a broad solution, but deep as well, right? Often you kind of have to make that compromise of, do I want a point tool that's really good at OT, but that's all they do, versus something that's kind of, you know, an inch deep and a mile wide. And we've done this long enough and, you know, kind of put enough time and resources to be a mile deep in these multiple areas. And one of the things we're off the bat on the operational technology side, for anybody interested in kind of living on that, is the Purdue model, right? It is that kind of OSI stack of the OT world, and how do we kind of rank where the levels of communication and who kind of talks to what. And so our ability to not just kind of capture the raw data of this is where these devices at and some of the properties are on them, but visualize them in a way that will have, you know, real meaning to someone who recognizes, like, you know, there's kind of a base policy of not jumping multiple levels here, right? Or someone again who's kind of designing this, the architect of network would probably recognize where communication should and really shouldn't be happening. And it's those great kind of like at a glance methods of, does this look right, yes or no, but still where, you know, a human kind of really, right, needs to make those decisions, right, needs to have that view of does something look right. Now you can't kind of hard code or machine learn everything in that, you know, these things are happening in my environment, and is that a problem, right? I think Bryan showed you a lot of our kind of out of the box content around risk factors and us finding things that are low hanging fruit, but there's always going to need to be that human element of, you know, is this vulnerability scanner hitting PLCs? Often kind of a no-no, right? They do Nmat port scans. OT things don't like to be port scans, things to be taken offline, reboots can happen. So it's one of those things where I think we get a lot of credit for doing not just our discovery here in areas that are hard to discover, but in this agentless, passively collective scan, you know, no active scan way that's not going to have an impact on this operational technology environment, which often those tools can, right? We're gap filling in those areas. Similarly, while this might be, again, both a kind of a security and an operational play, it's not uncommon for us to be brought in from a use case perspective, where, again, based off my boundaries and what I'm looking at, understanding, say, on the medical side, if I'm in a hospital, what devices are in the environment, right? You can kind of see there's a bunch of pull downs here around if my job is just MRIs, or I'm trying to kind of narrow in on there's a refresh or I have budget to get new X-ray machines, understanding, all right, well, where is stuff being utilized and not, right? We've had a few hospitals where, you know, one MRI machine was being used, you know, 50 hours a week and the other one 10. Right. And so clearly that wasn't, you know, well balanced. And it was just, you know, recognizing as those kind of requests or needs come in, what are the resources, where they're at, especially if you're a multi-site, multi-hospital or large location, and saying, okay, my utilization is 100% here and 31 here. That's a problem. Right. So maybe I need to move, you know, this 31% guy from this hospital, right, over into, you know, into Zurich. So those are the kind of operational use cases we can be helpful with, in that not just do I have these devices out there, but what's being used where, and that can apply to any device, right? And understanding, well, again, before I go buy a bunch of new things, maybe I just need to kind of move some things around. Similarly, if I kind of come back to that inventory bucket and drill down, say, on the PLC side of things, again, for people who exist in the OT world and need to have the kind of level of granularity where, you know, east-west traffic for these devices may never hit a core switch where we have like a large sensor sitting, right? So we have micro sensors and virtual sensors and the ability to get, you know, hang off a diode and get really down to that, you know, layer 5, layer 4, to see all the PLC modules hanging off of an engineering workstation and understand the really granular details of, this is Rockwell, right? This is Siemens. We're used in HVAC systems, right? To find those fire, power, things that your traditional IT tool that's been around 5, 10, 20 years will never be able to put an agent on. Your vulnerability scanners cannot, really should not scan. They'll never have a login to, right? And they'll never have this level of granularity. So again, this is areas where we're often gap filling of, yeah, we haven't really looked at those you know, large OT devices since we deployed them, and we need to know what's on them, version information, et cetera, because we see, as Bryan mentioned earlier, more and more of that connectivity between the IT and the OT world, right? colonial pipeline is a great example of the IT side being compromised and then looking for that hole into the OT world, right? And potentially finding it if it's not detected and closed fast enough. So that's where, coming back to Bryan showing you, the risk factors, a lot of it's triage, right? If you're in the IT or the SOC side, you have access to the SIM, you're seeing thousands, tens of thousands of events happening, alerts, whatever that is. Again, humans are kind of past the point where we've got so much data. Looking at every alert, even just the high alerts, right, is really not a filter enough. This is where our behavior analytics, the knowledge database that Joe hammered on earlier, is doing that triage for you, is really drawing your attention to these type of devices. These are the low, medium, highs, and critical risk that a human needs to kind of look at and make a decision on. Similarly, coming back to that level of visualizing what we see, I think one of the things I like is they're highly kind of role focused, right? You can have a dashboard with as many little dashlets inside of them, but they can be really targeted to only what your role, right, your job is responsible for, and kind of cut out the noise. It's great that we have all this IT and OT and medical devices in one place, but it's rare that one person's responsible for the whole world, right? So that's where someone could create these dashboards and really just like, all right, so I'm doing medical devices. I see you've got a lot of infusion prompts, right? What, from an asset perspective, not security, but asset, what's going on with the medical devices in this hospital versus the security side kind of down here a little bit, where if I want to drill down into the risk on those devices, I have that different view. And that's where, again, we all have so many tools. Nobody can live in a tool like Armis, no matter how great the data is 8 hours a day, right? Everyone has a pile of things to get done and 20 tools that are potentially helping with those tasks. We're really trying to present the ability to focus what you care about at a glance in that 2, 3, 5 seconds and get that questions answered with a real ease of being able to drill down. Okay, let me come back over into that those medical infusion devices and see if there's anything of particularly high risk there. And if you want to kind of drill down the rabbit hole of, okay, well, that device certainly seems to have some criticality on it. As Bryan showed earlier with the IT asset, we're doing the exact same thing on the medical device, right? Or the IOMT side. Those same alerts are there, the network traffic, the activities, right? And going through the activities, as he pointed out, this is where we're finding specific problems with a medical device, right? So for us to do that type of kind of assessment and profiling on anything, that becomes really kosher, and that ideally people want to work from the same tool. Nobody wants to have a different tool to log into, again, from the OT side or the IoT side than they do on the IT side, right? And everyone's working from the same list of assets, right? The same kind of view, that idea of a single pane of glass. Everything goes smoothly, right? As these things get created into tickets and they get routed to someone to do remediation, we all have the same list of data that's as up to date in real time, as fleshed out as possible, to allow okay, now I know why I care about it, right? These risk factors, what can I do about it, right? And again, Joe highlighted a little bit of that ability to kind of resolve those things, but the policies here that, okay, this happened, this triggered, can be anything from a basic alerting, and that alert's going to go over into your SIM, whatever that is, a workflow, it goes into your ticketing system to then, this guy gets notified, this guy has to approve, there's a remediation activity, right? Into even, all right, this is particularly critical, let's go ahead and quarantine it, right? So some MITRE ATT&CK framework has something particularly bad, right, from for the ICS world. How do I have that trigger, right, that activity become something like a quarantine, so I can kind of stop the bleeding because it is showing, it is a camera or it is an HVAC system or a UPC showing IOCs that's been compromised, right? Maybe something just hasn't been scanned in a certain amount of time. It's kosher to be scanned. And we can tell from the vulnerability data coming in, so we're gonna go ahead and kick off that scan, right? So there's a lot of potential integrations as far as us being a platform, which I think is really easy for us to pull data in, whatever that data source, but also push that data back out or leverage our orchestration capability, especially when the kind of clock is ticking, to say, hey, this is a particular problem. I want you to kick off this playbook in your SOAR, right? Or create this ticket in your ticketing system, or temporarily put this on a quarantine network so we can have time to kind of drill in and triage what's going on there. And then coming back to the dashboards, if I go over to the metal security, this is where, again, at the end of the day, risk is risk, and we're really trying to highlight where in this environment, PHI or PII information is going out, right? That's something that's kind of an immediate compliance value. Anybody on the GRC side or the compliance side knows it's kind of a big no-no, but that could apply to anything. It could be HIPAA violations, it could be FISMA, it could be classified data, right? It's just we're identifying the problem in a way that, as Bryan showed you with that kind of query language, is very granular. It can be really any combination of I care about this and I don't care about that. And then as we kind of highlight that, the ability to really be, okay, this has happened, what do we do now? All right, so I'll go ahead and pause there. If there's any questions, now would probably be a good time, or Bryan, you can kind of pick up the AVM side.
Yeah, can I do a quick time check, Joe? Do we know?
We're good. We have until you have about, like, say, 10 minutes.
Okay, perfect. I can hopefully do that in less. So just want to confirm everyone sees. Joe, can you see my screen?
I can. Yep.
Okay, and it's the console. Okay, so one thing that Armis has recently done was, traditionally when we first started out, we were reporting on all things vulnerabilities alike, right? So we've realized the power that is vulnerabilities and how much more value we can provide your vulnerability management teams that are out there, right? We understand that so many vulnerability management teams are just drowning in the amount of CVEs that they see. Right. Even if you try to list it out between, okay, I only want to see critical CVSS scores, let's just focus on that. Maybe even still, they could be extraordinarily overwhelming. So what Armis has decided to do is invest heavily into this dashboard that we're seeing. And I'm actually really bullish on it. We just recently kind of modularized, if you will, I think that's a word, with the vulnerabilities aspect of it to be able to enrich further on that. So if you look over on the left-hand side, we see vulnerabilities, right? We've taken the approach of, listen, Armis out of the box, its core capabilities understands devices, right? And that device context is immeasurable in terms of how can I easily figure out what vulnerabilities I should focus on resolving, which CVE should I focus on first based on the device context. So understanding what the device is. For example, I might have a critical CVSS score or CVE, living on, a Windows machine that's over in my guest boundary, right? Or guest network that's at the visitor center or something like that. But I have the same one over here that lives on, a server that's feeding, or a hypervisor rather, that's feeding, hundreds of other devices, et cetera. So just the context of being able to really understand what the device is a extremely valuable value add. But then we've taken it even further to be able to apply, again, passively, understanding, how exploitable are those CVEs though, right? We have critical, sure, but if we click here and I dig into what we just looked at, which was critical, highly exploitable vulnerabilities on servers, right? That was the title. If you guys missed it, I clicked on that. And really what it was is I click on this drop down, right? Again, these are these queries that they're a lot of fun ones, to drop down and add certain layers, etc. So very easy to use, but we create dashboards out of that, as we just saw, and we can create alerts around this through our policy engines. A lot of this is the value that we see out of Armis is focused around this query language, right? So what we're looking at is, again, okay, I want to isolate by my hypervisors and my servers, right? Just out of the box, don't show me any vulnerabilities that live on anything else. I only want to see the CVEs that live on my servers and my hypervisors. That's this portion here. We could add another layer to this that says, okay, even a step further, what about the servers that Armis found that don't have an endpoint agent on it, right? Because they're out there too. So let's focus on those, because at the moment we can't increase our licensing and get an agent deployed on that, or whatever the use case is. I want to focus on that. Or even further, what about my servers that have a public facing IP address, right? Exchange servers, DNS, etc. So what about those devices? So you see, you can kind of layer in and get very, very focused on the device context in itself. But then we scroll down, as we talked about, and said, okay, now of those, I only want to focus on the critical and the high, right? So you could imagine walking into work and saying, okay, I have, 30,000 CVEs I have to focus on. But you could see the layers that are starting to stack in that's going to reduce those CVEs down to the number we saw behind us. But we added in that context of critical and high. We're only looking at these. We can enrich these devices. And again, imagine any device that's relevant to your business, right? So we can apply this to medical devices. We can apply that Eden was just showing. PLCs, infusion pumps, nurse call stations, engineering workstations, SCADA systems, etc. All these different devices that at the end of the day, still a lot of times run certain, automations, the door automation types of devices that Armis picks up on. They're running a lot of times applications on those. So again, applying that passive approach of what vulnerabilities live on those and how critical are they? But then, of course, as we said, applying even further, I want to know and leverage that threat intel. I only want to know about this metrics that we have up here, critical servers with a critical and high CVSS score, but the exploitability of it too. I want to know how many times in the wild that we've seen these CVEs be exploited. And I want to only focus on the ones that actually have been exploited at least once, right? So we can focus on that. This one, it may be a CVSS of critical, but we haven't detected that it's yet been exploited. I want to focus on the ones that have been. How about being weaponized by a threat actor? Right, let's layer that in. Is somebody found a way to make this really easy to exploit through a Metasploit or something of the nature to be able to take advantage of that? Down below that, we're adding another layer. I only want to know about the ones that require a user, or that do not require, a user interaction. Meaning somebody, knowing or unknowingly, doesn't have to double click some sort of executable, be it through a phishing campaign or whatever it may be. This file that's been buried behind a PowerPoint presentation that somebody just found and slipped that in there, and now they double clicked it and boom, they're exploited. We only want to focus on the ones that do not require user interaction, which makes it even more terrifying. So all we've done is taken that layer of complexity, right, and got our vulnerabilities, our CVEs that we need to focus on down to 8, right, from thousands. We can go up to the top right, organized by boundary too, as we scroll down. Basically saying, or physical site too, right? So now we're isolating even further of saying, only show me the devices of the servers with these, metrics in here and exploitability on these types of devices living in this boundary, my critical sensitive boundary, etc. So as we dig in, I only have a couple things to show further on this. So now we've prioritized substantially. These are the ones I need to focus on right now, right? We can add business organizational priority to these. Meaning it may have a NIST NVD score, CVSS of critical, but in all honesty, if let's say, for example, this CVSS of critical or et cetera with these description lives in a boundary that I know for sure has an ACL in place, it's going to firewall that off. This means nothing to me. I don't want to prioritize this. So we can go through and apply this to all devices that live in that boundary, for example, as low, for example. And here's why: compensating controls, acceptable risk, whatever it may be. Again, getting into the more management side of these, and again, prioritization. But as I click over, one of the most powerful things that I'll show in the last portion of it is the matches, the device match portion of it. So again, here's essentially saying I found this CVE to live on 3 devices across your network. And imagine that, again, this is a demo environment. Usually in client environments I see, it's thousands of devices, if you will, but we want to isolate this down to the device types or the boundaries and only focus on these. So this is a perfect example. If I'm looking at this CVE and I'm like, okay, I need to take care of this CVE, but which one should I start with first? The hypervisor or the mobile phone or the attendance system, right? I'd probably want to focus on the hypervisor first, simply because it's obviously a hypervisor, right? So that device context is called out very well right here. And the last thing I will show is the ability to automatically resolve this, right? And unfortunately, because it is in a demo environment, I don't have it, but we are able to glean the vulnerability off of understanding that once we've determined, hey, we know what this Apache log4j 2.15 vulnerability is associated with. This is probably actually a bad example, but take Windows, for example. Windows Server 2016, build and revision number, etc. Once we've determined that that's been patched, either through traffic inspection or an integration with the endpoint or SCCM, for example, then we're able to passively and automatically mark this as green and resolved and allow you to focus on the ones that have not yet. Or as Eden said, trigger a scan to reach back out and confirm on these devices, right? If I have this criteria met, I want to automatically trigger a scan to reach out and through our scanner and touch that device to scan it to see if that vulnerability still exists on that device. So again, we've gone from an overwhelming amount of CVEs, prioritize them by focusing on business critical devices and applying additional threat matrices within there, like exploitability scores, to really prioritize that CVE to focus on the most critical CVEs as they pertain to the most critical business impactful devices. And now we've gotten into the management portion of that as well. So I think there's a little more than 10, sorry, Joe, but that's what I wanted to show from a asset vulnerability management perspective from Armis.
Good. Thank you, Bryan. And I want to thank everybody. I know it's a beautiful day out there. It's, in the summer, a lot of people on vacation. Thanks for taking time out of your day. There's also a zero trust white paper we've shared with ATARC. It's a depth one, about 9 pages. It just came out, not even like 4 days old. And then feel free to reach out if you have any questions. And I thank everyone for the time.